right, let's take a look at another thermochemistry problem here. This problem says, what is the specific heat? So right away, just by reading those first few words, I know I'm going to use my thermochemical equation, Q equals MCAT. That's just a cute way to remember it. This is not actually the letter A, I know that. It's a triangle, which represents the letter delta, which means change in, but that's just a fun way to remember it. So once again, Q equals heat, M represents mass, C represents specific heat, which we're looking for here, and then delta T represents change in temperature. So those are my variables here. I can go ahead and label this as C. Actually, I'll put a question mark by it because that's my unknown. It says, what is the specific heat of titanium if the temperature of a 36.7 gram sample, that I can box in and label as my mass, has its temperature increased by 4.8 degrees Celsius, that I can box in and label as my change in temperature. Sometimes they give you a starting and an ending temperature and you have to subtract. That has already been done here for you. So the 4.8 is the difference. And then it goes on to give me 91.6 joules of heat. And my variable for heat in this equation is Q. So now that I've read this, I'm also given a hint here. Your units for specific heat will be joules divided by grams times Celsius. I'll show you how that works in just a minute. Now we can go ahead and plug in some of these values. So I've got 91.6 joules for my Q value. My mass they give me in the problem, it is 36.7 grams. My specific heat is unknown. So my variable C here is my unknown variable. And then 4.8 degrees Celsius was my change in temperature. Couple of important things to note. Specific heat and heat are not the same thing. A lot of students get those confused. For this particular problem, it specifically says, what is the specific heat? So we're looking for C here, not for Q. A lot of my students, they can plug this in, no problem, but when they go to solve for C, they get kind of tangled up. It's the algebra piece that usually gets them. So how do I isolate and get this variable C all on its own? Well, it looks like I'm going to have to divide both sides by my mass multiplied by my change in temperature here. That way my change in temperature will cancel and my mass will cancel, and the only thing left on this side of the equation will be my specific heat variable. So remember, whatever I do to one side of my equation, I must do to the other. So I'm going to divide this side by 36.7 grams times my 4.8 degrees Celsius. So right away I can see how my units are going to be funny. It's going to be joules divided by grams times Celsius, which is the appropriate unit for specific heat capacity. And another important thing I want to point out here is notice how I'm putting parentheses here in the denominator. When you punch this in your calculator, you have to remember parentheses around that denominator. Otherwise, your calculator wants to divide first when it really should multiply first. So punch in your calculator 91.6, hit the divide by button, open parentheses, 36.7 times 4.8, close parentheses, and then hit equals. If you punch it in your calculator, you should get a rather small number. For this case, the value of specific heat capacity, and I'm just going to round to keep things nice and pretty here, should be 0.522, and it's joules divided by grams times Celsius. So that is the correct unit to use here. Sometimes it's calories divided by grams times Celsius, but in this case, because we were given a value for Q in joules, my specific heat capacity should also be in joules divided by grams times Celsius. This has been a Rodriguez original production. I hope this helped. Go back, study your notes, look at more examples. Good luck.